Okay, so the next problem was, let me actually, there we go. Okay, so next problem asked you to find the temperature of a gas that occupies 0.45 cubic meters and 1.95 atmospheres, and at 0.654 moles. It tells you that it's neon, and I went and started to look up neon before I even really read the problem, but then I realized, wait a second, the problem tells me what the moles are. And since the formula is pressure times volume equals the number of moles times the constant times temperature, we don't need to know any other information than the number of moles. Doesn't matter if it's neon. It doesn't matter if it's hydrogen. It doesn't matter if it's cheese. If they tell you the number of moles, you already have what you need to know for the problem. Okay? All right, so with the number of moles, the volume that it takes up, 0.45 cubic meters, and the number of pressure, we can go ahead and create our formula, with one exception. This time, we're talking about cubic meters and atmospheres, not pascals. So if we're talking about atmospheres, we need to find a different constant. The constant that we have this time, and I just Googled it, and it's a pretty famous one, is the other famous one that's usually used. Now, there's usually two different versions. The previous version was 8.314472 cubic meter pascals per Kelvin moles. This one is a little bit different. Oh, no, I'm sorry. I use the same one. On the next problem, I use a different one. I use the same one this time. But what I did do is I switched over the atmospheres to become pascals. So there is a different R value, but I didn't use it here. I changed atmospheres to pascals using the one that your teacher gave you, because that is the correct conversion. So doing dimensional analysis, or whatever you call it, it's pressure with a bit of conversion attached to it, times the volume, times number of moles, times our constant, times an unknown temperature. PV equals nRT. Okay, so the atmospheres was 1.95, we were told. Conversion is 1.013 times 10 to the 5th pascals per 1 atmosphere. Multiply them, the atmospheres cancel, leaving the number of this times this in pascals. Then you multiply that times 0.45 meters, and you get 88890.75 cubic meters pascals. If you take the number of moles, times it by this, the moles cancel. That number times that number becomes 5.4376 cubic meter pascals per Kelvin. Same thing here, we just solve for T by taking this number and dividing it from this. Divide both sides by this number, that cancels, and surprise, cubic meter pascals, that cancels, leaving Kelvin on top. You get 16347.37 Kelvin equals T, the remaining value over here, never canceled. And since we were doing sig figs, there's three numbers, we do 3 numbers, it comes to 16300 Kelvin equals T, or 1.63 times 10 to the 4th Kelvin is your temperature. And again, please do not have it as degrees. It's not degrees Kelvin, it's just Kelvin. Okay.